Okay, back on.
But I should be
So,
working.
do you want questions during the talk or just leave it all till the end?
Probably maybe at the end, if that's cool.
All right, leave it all till the end, no problem.
Might make it easier. There we go. Cool. Thanks, William. So yeah, my name's Andrew. I'm an AI consultant engineer at Arinco. And this is relatively I'd say like a non-technical, it's not a code-heavy talk. It's actually, I like the ideas. For me, the ideas are more important sometimes than code details. But overall, about 2 months ago, one of our clients had a big P1 incident. The servers were down. My boss was spent a late night trying to try out some of the issues, and then he roped me in to come in and help them. And what they wanted was some observability, a bit of confidence in what could be done. And so I joined the war room late on a Thursday afternoon. And so before I start, I thought I'd share awesome ideas and thoughts by Birgitte Bockler. She's from ThoughtWorks, and she does a great article, Harness Engineering. And she talks about the idea of feed forward and feedback. And they're the things when we're doing agentic coding, where we can help steer the agent and get responses from the agent. So feed forwarding is instructions in the context doc. So we steer the agent to act in a certain way. And then we have feedback or sensors, is once the agent's executed its work, we can feed it back. So we can use logs and linters and tests and information. And then a sort of a loop construct. What we can do is create this nice feedback loop where we guide the agent, get information, and we steer it back into it. And we're evolving and we're iterating through the actual agentic workflow. So I find this pattern awesome. I forgot to start my stopwatch. And so the incident started a couple of days before. Quick summary, it's a big legacy .NET application, .NET 4, sitting on on-prem servers, IIS. And effectively the website was seizing up, like the P95 response time was like multiple, 325 seconds. And so that was the context I had, but I had probably lesser context in the start, was that I came in from scratch, had no grounding, and I should have said Arinco were like AI first consultancy, but for the first and foremost is AI, in my mind, that's how I'm going to start. That's my starting point. And so I sort of call it 5 days in summary and an empty folder to start, because that's all I had. I didn't have anything. And so on the Thursday night, I join the war room, I get some information, we get some logs information, I make a quick analysis, get some logs, and I make a summary finding. On the Friday, I had better access to their system. I didn't have access to the code base. And then late evening on the Friday, I had access to their code base, and I identified some remediation, some core issues for the application to make an immediate remediation plan, which they executed on the Saturday. The Saturday, they deployed those changes, the thread settled down. The incident was still high, but we'd bought some time. Effectively, the server wasn't crashing anymore. And so we'd bought some time. And what they needed was a remediation plan, but also a data-driven and evidence-based approach to have a remediation plan, but also tie everything back, not just make an ad hoc changes, not make just sort of a piecemeal, but every change that was going to be made, we have evidence-based and factual-based information. So that was the Saturday and the Sunday, and then the Monday was the analysis, remediation plan, and delivered it to the client. So the Thursday for the starting point was building up context. I had no context information on what was occurring. It's a multi-layered API application, multiple mobile apps and web consumers and different channels, but too much information to take in all at once. And so my plan really was, that was from my boss. All the quotes in blue are off from my prompts into the CLI. And that's all the information I had. So I started an Agents MD with that quote. And what I'm doing is I'm building up the instructions. My intent is to build up some layers. And so on that, this is the Thursday evening, I started that Agents MD. I got some the event logs from the on-prem server, IIS logs. And then I got a Claude and Copilot to read the parser to start parsing out those files to get information about the what was occurring. I built some HTML dashboards to give some visibility for the client, and then it sort of identified what was occurring was that thread exhaustion. All the threads were coming up in the server, and the actual reached a deadlock point where the server was in effectively like a deadlock state. And so part of that opening slide that I did was the idea of build tools, not prompts. To build everything that we do, rather than make a prompt in, think about building out a particular tool to solve a job, to have a reproducible way of doing a task, and not just have to rewrite the same thing again and again. I might actually sit down. And so these are literally quotes that I put in. Was build the event log parser, put it into a JSON format so I could read it, so I could understand it. And then on the Friday, where I'm doing more coding analysis, based on the previous night, was beginning to have a hypothesis that there was, based on the Claude's information, that there was probably a looping call. And so I made up the blue one in there. Could the server be calling itself? Could it be doing that? And Claude said I was typed in and I already had some context data. And Claude looked through the data and said, it looks like it can. And then my second line is I eventually got access to the code base. And then I said, I didn't even understand the code base, but my question was, can this particular application flow be calling itself? And then going through the code, looking at the IIS logs, going through the event viewer, the answer was yes. And so what that was meaning was the application was coming in, a thread was coming out, but because of there's a blocking thread and the server's under load, that initial thread's blocked and will never be answered, so it comes into a locked. And the old-fashioned CLR in .NET 4 would just spawn another thread, and again and again and again. So doing that within hours, I identified that and other problems, and I made the immediate remediation plan. And I said, we need to do this, let's deploy it. And so that's what they did. On the Saturday morning, they deployed it, and we watched the graph go down. And the P1 incident hadn't been resolved, it hadn't been changed. But what we'd done is bought ourselves some time. We've reduced some pressure. And then this time I hadn't properly understood the code base. All I did was a targeted spiraling through the code base. What we needed to do was really solve the problem. And so I mentioned that the client needed to do an evidence-based approach to solving the problem. And so the Saturday and Sunday is really about, for me, like the story of this. What I want to communicate was what I needed to build out was a foundation for being able to tie everything what's occurring and it happened in the previous week to all of the targeted code changes that needed to be made. So I started with this. I didn't have initially access to the code. And so I just made a folder, Agents MD, and then Claude, I make Claude's just a pointer to Agents MD. And so it's the instruction, it's the system map. And all of these folders are storing the context information, building out the layers. So I've got that there, is the idea of building out is what I want to do, is I want to create a context, be able to stop and start a session, and get back to the exact point where I was. And also run agents in parallel, Codex, Copilot, and Claude, and they're all within the same context. So I'm not sharing Claude session or Copilot session, I'm storing my context. The application context. So these folders that I've got here, it's like GitHub, it's Copilot instructions, it's a pointer to Agents MD. Agents MD, the core of it, the system map. the pointer to all of the documents. It's got all the tribal knowledge, the conventions, the finding. It's not massive, but it's acting as I call it the system map. The Claude MD, a pointer, the data, all my data that I've ingested, IIS logs, and then eventually I imported all into like DuckDB, a relational DB. I've got my findings folder where I do, it's like a sandbox. So I would make a query, do some analysis, get codecs to make a query on IIS, version, blah, blah, blah. And I'd put all raw findings in there. The initial investigation, which I put out on the Friday night, I stored it just so there was context of the understanding. The repo, when I eventually got it, went into this context folder. The reports, all the structured, the communication documents that I provide to the client. So the output of all what I've been doing. The reviews, the tag team, when I'd get Claude or Copilot to review code or make a suggestion or do analysis, I would constantly go, Claude did this, review that, and get codecs to output it. And it's like tag teaming. And it's providing effectively a conversation and the agentic workflow within that, and then the scripts or the tools that we've written so they can be reusable. An agent MD knows about these tools, the equivalent of a skill. A Python, an IIS log parser is in this, blah, 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 and it does that. So on the Saturday, what I need to do was build out this layer. So all of the data. I've got IIS logs, event viewer, app insights, and what I did was I pulled it all within to one data layer. And I was running ad hoc. I didn't have proper access to their system. I had access to App Insights, but I didn't have right access to Azure. And so I pulled it all in locally, all of this data, to cross-correlate it. And then that's the question I put is, what DB should I do? And I said, DuckDB, because it's easy, or it's a CLI, all agents can call it, and it's simple. And then the other part is I wanted context. I need to start understanding the application. And so what I did was I pulled in a tool that I've developed. It's on GitHub, it's on MIT license. It's the ACF that's effectively, it produces repo documentation. It's grounded in verified steps. But what it does is a multi-session steps with different agents, reviewing the code base, producing documentation, get steps to verify it, grounded in facts, make sure that they're not hallucinated or incorrect, and then rinse and repeat. And that's effectively ACF. And so what I wanted to do is I wanted to be able to chat to the code base, but I knew I was about to start getting the agents to work on the code base. And I wanted to make sure that, and I want to trust, that the agents were grounded in facts. The grounded would not just hallucinate, not just one code scan, but a verified code scan where it's not going to hallucinate. And so ACF acts like a system map. It's within the agent's MD. There's like a retrieval discipline. That its job is for the agent when it's say do feature X or whatever, how does this part work? The system map is telling it where to find it. It goes, you want to do auth, it's in this file, more than likely the method's called XYZ. And the point is to reduce token usage, to make reduce context rot within context window, and make your agentic workflow sessions move much quicker. So sort of quickly in summary, I did that on the Thursday and Friday. And then the Saturday we put out the fire. The graph sort of went down. There were still issues, we're still fixing things. Sunday's building out the platform, and then Monday's the analysis and the handover to the client. What happened within these days was almost 6 million data points, rows of data, 600 a massive monolithic code base. And all of these data points were correlated and put into context and all date correlated and everything interrelated. That's the data and context aspect. The simple sort of investigation was, Thursday, joining the war room, having no context, pulling out IIS logs and making an additional report. And also I quite like I really like, probably as we all do, as a consultants or developers, is investigating things. I really like investigating things. I like fixing bugs. It's interesting. But I had to keep an open mind because the application was so monolithic. There's no chance I'm going to be able to solve it all together. What I wanted to do was build up a layer and a grounding and a context, and then take it in a methodical way. So Friday, I had the insight, I got Azure, I identified the deadlock, but also 3 or 4 critical fixes, and we said, let's deploy them straight away. And then Saturday, they deployed it, so pressure's off, but take a bit of a breath and pull in, do the onboard ACF, pull in the data. Sunday, I'm still making fixes, and I'm not writing code for it. I'm making recommendations. I think you should change this line of code or change this block. Here's a snippet, because I didn't have write access to it. And then on Monday, on Sunday night actually, I was confident enough to go in my head, I know the answer. I know what the problem is. And it was there's multiple, it's not just one thing, but I was confident enough on Monday that I could produce the remediation report, and I could say conclusively, this is why it's happened, this is on this date, and it tiered away from all there. And then critically what I can do with the code-based understanding, I can correlate every remediation plan, every remediation changed to a data point, an error log, something in the exception flow. And so it was all correlated between issues that had occurred in the previous week. And then that's sort of in the time, I've been saying like a week, I've been saying 5 days. But in elapsed time, it was 24 hours. It was 3 days. Thursday was 3 hours. Friday was, I was on a different engagement, so I'm sort of doing this at the side. Friday was 4 hours. Saturday was 6 hours. Sunday was 6 hours, 7 hours or something. And then the analysis and remediation was done on the Monday. So within all of that, the space of elapsed time, 24 hours, I was able to achieve that. Go from nothing, grounding, an empty folder, to a full understanding on the Sunday night when we were not live streaming, but evaluating. I was able to connect it to all app insights and everything, and the client could ask, oh, what's happening now? Why is that occurring? And I could type into the context layer, and then I can say, oh, that's occurring because of this. The thread issue that I identified the other day, that's occurring because this line of code is doing that. And so how that was all possible, why was all that possible? Why could I do all that in 24 hours? Was the context, the starting point, the agent's MD, the system map, starting everything and then correlating and having a structured approach to tying everything together. And so what I could do with the shared context, so Copilot, Codex, and Claude would all, Copilot and Codex all read Agents MD. Claude, you have to tell it, hey, read Agents MD. You just do a pointer in Claude.md. But that's the context, and I use that, the Agents MD as the metaphor for providing the context. I could shut my computer down, close all the CLIs down, start again, and the context is there again. And it rehydrates it. The data layer, the ingestion pipelines that I helped build out, and then eventually the data layer I could cross-correlate. That was fantastic, amazing, because then I could provide evidence to all of the what's occurring, but also help me understand it. To go, I don't understand all these, these events and why is it doing that, but to be able to make coherent queries over multiple data sources helped me understand it, as well as the agents. The rapid code investigation, as we all know, AI is awesome for spidering through and giving us hallucinations. So not hallucinations, giving us insights, but it also can hallucinate, so it's fallible. But the speed that it can do it is amazing. The reporting aspect, to build out charts and graphs and KL queries, and I would save them. And at real time, the client would say, what's occurring now? And I could just do quickly a graph or thing and then send it to them in real time. That data reporting aspect was foundational. And then I touched on that, the multi-agent workflows, the ability to cross-work with different agents. To do, Copilot's working on this, Codex is doing that, and then for them to tag team off each other. You can do the same thing, you could run 3 Copilot CLIs if you want, but I find it can sort of slow it down. But if you're lucky enough to have different providers, that cross-agentic workflow is extremely useful because they can run on independent tasks, but then also circle back with a shared context document to agree on a particular design or argue about a particular design. What worked, what was the good takeaways were all of these sort of the LLMs and the models are fantastic, but a hypothesis from a loose question. One of the questions that I said is, could the server be calling itself? And that was on the Friday. And then that was foundational. And then we go, oh, well, how do we prove that? And then eventually we got like some PowerShell script to run on the server to pull out DNS information and all that. And then we went, yes, 100% it's true. But the ability for LLMs and models from a small little snippet of information to infer a large amount. But I'd also flagged that that hypothesis as well was based on the data that I've been accumulating. So it's collective as well. The similar one, the scale from the single instruction on the Friday when I went, I think it's this, Claude, do a targeted, you've got a 600 files to look at. I want you to do an analysis on just thread, things that could be producing a thread, threading issues and performance issues. For a human to do that, or anyone to do that, could take a considerable amount of time, but you'd need domain knowledge. You'd need an understanding of all the inputs, the downstream, the upstream. It's extremely difficult. LLMs and models with their vast sort of grounding in information, they can quickly do that. And I will flag that that was part of it. I did that analysis, but I did get Claude to do it, and I got Codex and Copilot to both review it because I wanted to be certain that its findings were correct, that it wasn't hallucinating a false positive, because I was about to make recommendations, so it needed to be grounded in truth, in fact. The document, as in what I mean document without a write-up phase, is where possible, record everything, store everything. When the prompt comes back, I would say, that's great, save it to an MD. Because I actually think about, I was thinking in an analogy, it's like Bitcoin mining, is when we're doing we're burning up tokens. It's, in a way, it's like gold. You don't want to throw away the gold, you may as well store it. And so that's what I think about in documentation and context, is not everything, but sometimes things are gold, and if it's gold, store it. And save it for the memory, save it for the context, because you can reuse it. Rather than make the same prompt tomorrow and burn the same amount of tokens, it's wasting money, it's wasting time. The context carrying across over days, shut my computer off, everything gone, start again, bang, it's just there. That's amazing, that's awesome. And then the cross-correlation, that data layer, putting everything in correlated, and once everything was correlated and like even Git history and down to the dates, we could actually pinpoint changes and go, oh, okay, sure, so this happened then, the change when we did this, we can actually see the improvement in App Insights. Everything was correlated. And then what didn't work is, again, it's more like LLMs, I would probably say, is they're fallible, and I'll go back to the first slide that I did, is the tools, the steering and the feedback and feed forward. And the blue ones are my quotes from the chat Claude session or Copilot session, is sometimes oversimplify things, not understand the context, or be too eager to answer a question. And I would say, no, that's too simple. And then the opposite, don't make it too complicated. You're overcomplicating things, you're overbaking it, you're over-engineering things. And that's part of that. I would think it's, in a way, make a prompt where you steer, or an instruction, where you steer the agent to not overcomplicate things. Or, if they do overcomplicate things, feedback and say, no, that's too complicated. Make a memory, put it in the tribal knowledge into Agents MD. Don't in the context, use this particular pattern. Don't unnecessarily introduce complexity unless it's needed. The complex task drift, you're probably all aware, but that, there's me typing in, what are you doing? Is sometimes I do a long running task and I wouldn't checkpoint it. What I should have done is make a plan, checkpoint tasks, and report back to me when you've done task A, B, and C, and D. Sometimes I would, just in a rush, I'd make a long running task and then it would go off and then I'm just sort of waiting on something and it hasn't returned, it hasn't got a result. And so that's me saying, what are you doing? And then I can see some of its output and then I go stop, because it's just gone down on a different path that was not desired. But I'd also tie that back into that feeding back as well. LLMs, confident, not true, the pattern inference, the convention inference and behaviour inference that all models do. They base it on their data. They look at what they've trained on. That EF framework works like this. A particular library works like that. And so it won't look at the code. It won't look at the particular issue. It'll infer it. It'll just infer behaviour. And in that case, it's not looking at the code. It's not looking at the context. And so that I would say that's not true. Where is the code for that? Because it's effectively, it's hallucinated it, but it's inferred it from its training. And so in awareness, so if you're aware of that, then it's more you need grounding. It's extremely difficult to avoid that. But what it basically means is always require verification from the model and not just take it in blind faith. Know when to hand off. This is when me being impatient on the Sunday night is starting to do, I need to make like a code change, and Claude's just taking ages, and then I go, okay, fine, I'll get Copilot to do it. And Copilot did it within like 15 seconds. And then I stopped Claude and said, no, stop, Copilot's already done it, look at the output, blah, blah, blah. What I think I mean by that is know when to steer. And sometimes it's okay just to stop and go in a different direction, because you're the driver, you're the orchestrator of these, and they're the tools to use them. And then, yeah, a pattern matching, which is similar to inference and convention behaviour, is it just goes on patterns. So like we made a particular change on the Saturday night, and then Claude was going, the exception's not related to that. And I was going, of course it is. Because we deployed the test, and it's in Agents MD. We said that we did a test, and the testers did a performance test, and it was fine. And what it was doing is Claude looked at the exception, did pattern matching, but didn't pay attention to the context. And again, that's an extremely difficult problem to solve, but it's also about verification, and don't take everything that the models say in blind faith. And so that sort of in finishing up is what can you do? Like, you know, and I would probably say I take, not the data-driven approach, but I'm doing an engagement for a financial institution. I'm in the scoping and design phase, but I actually do this approach the same. I've got all my workshops, I've got all my findings, I've got all the Copilot transcripts, and I've got it in because I'm building context. And when I actually start doing coding, I can correlate all the transcripts and the workshops and all the findings into it. And so starting from the bottom is ask for reproducible outputs. Build tools, not prompts. Is charts with Python scripts. Don't get it to build a chart, build a Python script so you can annotate it, so you can change it. So when the client says, can you change the heading, you don't need to burn tokens. You just change the Python script. The cross-validating across sources, not just one source of truth. I like that line. One's a hypothesis, maybe. Two's evidence. Three, more than likely, is confirmed. So if possible, if you can have multiple data sources and they all suggest the same thing, that's extremely useful. More thinking and polished output is more, it might seem structured, but sometimes I can be a bit like hit and miss, but separate, have a sandbox, a raw folder full of dump and it's all messy information and a structured output, and that's okay. Don't try and combine them all together. It's good to have a messy sandbox that the client doesn't see. Yeah, direct, don't delegate. I've been touching on it. It's the steering, it's the feedback and feed forward. Is don't just assume that the agent will do what you want it to. You're the driver, you're the steerer. Structured output as you go. Write, good documentation, be consistent, have a discipline. Everything that's good, everything that's gold, save it to a document, save it to the context. Remember this. Running tools, not necessarily ACF, but anything, LLMs, models, hallucinate. They've got all these behavioral and inference problems. Ground your repo. Don't trust that it's going to understand it. Write a scan over the doc, save the doc. So each time when you come into the repo, you've got some grounding. So the LLM doesn't have to scan the entire repo to get some understanding. The data layer first, it's optional, but building up that data layer approach consistently pays off over time. I've sort of got it up there. 1 hour or 2 of setup saves days and days of time because you're not reinventing the wheel. And then the last one is, I think, in essence, I think that's the sum of this talk, is to build up a central system map. Agents MD serves that, and it provides the context, the starting point for agents and multiple agents to work on the same approach as a starting point. You can restart, you can start close your computer down, close the CLIs, you can come back, and you're back at the same place. And critically, the agents are back at the same place as they were. And that is about it.
This is microphone on. There we go. Before I sort of hand over to the audience, that library ACF that you showed,
Yep.
That's yours, right?
Yep. Yep.
Cool. And anyone can use that?
Yeah, it's MIT license, so it's just on GitHub. It's IMIC being software on GitHub.
Yep.
But it's got instructions, you can run it yourself. It's agent agnostic or model provider agnostic, so it works on Claude, Copilot, Codex, and Gemini.
All right, cool.
Yep.
Yeah, I've heard rumours of this in the office. I haven't seen it yet, so better go and have a look at it. So anyone else got questions for Andrew? Yeah, one over here, sir?
Yeah, I've got 2 questions.
Yeah, hang on, I'll run over. Yeah.
I'll just try and remember the first one. Great presentation, by the way. Thank you very much. So first question is, did the agents got off tracks at any points, and how do you actually steer it back to on the right track?
Yeah, that's the tricky thing. I would use that word, have a task and have checkpoints. So
Okay,
make a plan and decompose a plan into multiple tasks, and then have it checkpoints. So like have a plan MD or equivalent with individual tasks, and then get the agent to respond and say, I've done task A time into task B, and then you can either manually do a checkpoint, or you can get the agent to say, hey, at the end of task A, describe what you've just done, as an example. And so maybe if you want, depending on the context, you could be reviewing the code changes that it's made, so you're actively steering. But that idea of having a decomposable task, I think is a good one. And when you say to an agent, run a particular checklist, it's more than likely to going to follow it.
Yes.
Rather than just go, I'll make all these code changes, you work it out, you decide the order. That increases exponentially the likelihood that it will go off track.
That's great. And second question is, how do you actually feedback? You're talking about feedback, right? To the agent. What do you do about that? What is the process?
Yeah, it would be the data within some of the analysis. So I could go part of like I had sort of building up the context layer, building up the understanding of what the problem was. And then each piece of data I was feeding back into like the agent's MD or some of the findings. And to go, this particular, like one of the queries had like 18 or 20 DB calls all at once, and it spied it off into it. And then that was sort of, the context wasn't aware of it. But what it was useful was to feed it back into the context so all the agents became aware that that was a fundamental flaw of the system. And then the other one is that feedback is direct feedback, is when they either not answering a particular question, or they give the wrong answer, or they do inference, behaviour inference, feed back to them, and then also make a memory for them, or say, record that. Ground this in truths, follow this particular or citation, and then other ones is useful, is provide a citation. So if you've got a particular finding, write a citation based on a particular internet source, as an example.
That's cool. Any other questions? Yep, we're going over here.
Hey Andrew, this is Rajesh here.
Hey.
I have a question regarding the context size limitations, especially with the investigation that involve lots of data and long conversations. At some point, you will reach the limit of the context size. Then you may need to start a new conversation, and it will lose all the context, right?
Exactly, 100%. And then that's the difficult and part of like that context management, and this idea that all of these files that we were just looking at it, Agents MD was 500 lines as an example, which is not extremely massive. But part of that idea is to reduce, where possible, vast amounts of data. So Agents MD acts as a pointer to other files. So it does not need to keep it all in its context window. So that's an extremely tricky problem to solve, but my approach and approach in here is to keep everything, the system map, enough information in the documents for the agents to discover, but some particular tasks by their nature take a lot of context. They just do. Like a code base, it does take a lot of context. A lot of data does take a lot of context window. And so in that case is to try and reduce that, to chunk particular things up. But I would probably say that there's no clean answer to it. And what I do is to avoid that context rot, is what I was trying to communicate, is I actually shut the CLIs down and start again. Because you would know the expression context rot. When your context window is filling up, it becomes less precise. And it's actually, in a way, it's not garbage collecting, but it's starting to take out information that it doesn't think is relevant. Which for us with solving tasks, that's not a very good thing, because it might be discarding things that we don't want it to. And so then it might just go back to its training. It might just go back to its model data. But the challenge is to how do you keep things in context without bloating? And so in answer to your question is to try and keep your pointer files brief, accept that some things are going to bloat the context window. And when you've bloated the context window, save the goals, save the data, and then start a new session. You can either compact or this or that. I actually just tend to close the CLI and start again, because I want to be confident I'm starting from a fresh, empty base, if that makes sense.
Cool. All right, maybe one more oh yeah, we've got one down here. Hold on. So everyone online can give you and hear your voice.
Yeah. Would you say having structured logging on an application was the key to actually give that context in the application, what's going on? Like having that good set of logs produced from the application was the key differentiator for the agent to sort of track through and say, yep, that's the application flow and all that. That's where the bottleneck is, or that's where the loop happens. You reckon that's the differentiator?
In this case here, there was no structured logging. I had to infer the structured logging from the IIS logs and the stack trace and the event viewer, because there was an old legacy .NET 4 application that had bad telemetry. They only were putting data out to App Insights a couple of days before the incident, and the whole logging, the structured logging was effectively broken. So in answer to your question, yes, 100%. If you had structured logging, it would have made it so much easier, because as we know, structured logging has got all your data points and enough context. I, in a way, had to reinvent structured logging based on all the archaic reading IIS logs, reading the event viewer, reading the dump, etc., and effectively hydrating, in a way, the structured logging. I did, 100%, totally, exactly. Which is obviously not the most, it's one of the most inefficient ways to do it. But I had no choice, because there was no structured logging.
I hope you put it back to the recommendations.
Yeah, well, it was, it 100% was, yeah.
Yeah, definitely. Oh, wow. Maybe we'll call it there. Thanks, everybody. Thanks, Andrew.